Networking in Linux. In this nugget, we'll talk about how to set up networking on your Linux machine. We'll go through some of the basic configuration tools and configuration files that control networking, and we'll also look at the tools and the commands that you can use to diagnose networking problems on your system. So pull up a chair and let's get networking. Let's start out this nugget by taking a look at a diagram of my Linux home network. So what I've got on my home network is I've got two machines. I've got a desktop machine and I've got a laptop machine. Each of these machines has an Ethernet card, and I use an Ethernet cable from each of them to plug into a DSL router that I have. Now the DSL router that I have is a Linksys 4-port router, so it can handle up to 4 connections from local machines. Alright, that router I think cost me about 60 bucks. And I've seen them sell on eBay for $15. And this is the key to creating your own little mini home network. All right. Then that router uses an Ethernet cable to plug into a DSL modem that I have. This was supplied to me by my internet service provider. When I signed up for DSL service, they sent me a DSL modem to use, and that modem in turn uses a phone cable to plug into my wall, and then eventually that gets me out to my ISP, which eventually gets me out to the internet. All right, so how does this all work? Well, the router is responsible for routing traffic in my local network from the outside world. So for instance, if I'm sitting at my laptop and I open up a web browser and I bring up cbtnuggets.com, well, that request goes out to my router, out over the DSL modem, out eventually to the internet, and then it goes to the CBT Nuggets web server. It serves up that page. It comes all the way back to my router, and then my router funnels that information back to my laptop to display it on the screen. So I could be browsing the web from my laptop, my desktop, and potentially 2 other machines from my router. Okay, and it takes care of routing the information back to the correct machine from the outside world. Now, my internet service provider assigns IP addresses dynamically, so it's using the DHCP protocol, the Dynamic Host Configuration Protocol. So it assigns IP addresses dynamically, and according to the modem, it just has one thing plugged into it, so I get one IP address from my ISP. That IP address is given to my DSL router. All right. In turn, my DSL router is configured as a DHCP server for the local network. All right. So it gets the IP address from my ISP, but my laptop and my desktop get local IP addresses from the DSL router. Okay, so for instance, my desktop gets an IP address of something like 192.168.1.101. Okay, and my laptop might get one like 192.168.1.102. Okay, and remember from our discussion in the intro series that these IP addresses are local IP addresses. Anything that starts with 192.168.1 something is a local IP address that's cannot be seen by the global internet. Okay, that's just its IP address on the local system, and that's what the router uses to route traffic to it. That's also what these machines use to reference each other. So if the desktop wants to ping the laptop, I would say ping 192.168.1.102. All right, so that's the way my local network is set up. Now let's move out to the Linux screen, and I want to show you how to configure this router so that it behaves just like I was explaining in this diagram. Now when I bought my router, it came with an instruction manual that said if you want to configure the router, open up a web browser and type in 192.168.1.1. That's the router's address, okay, on the local network. And I type in a password, I get to the setup screen for my router. Now this isn't going to be exactly the same for every router, all right? It's going to vary from one to the other. If you got your router used or something, you can always look up the manuals for them online somewhere from the vendor's webpage. All right, so let's just look at the kinds of things that can be set up on the setup screen of the router. The very first thing is it says to obtain an IP address automatically. That's because my ISP uses the DHCP protocol to assign IP addresses, so that's why this is set this way. If I was plugging my router into a connection that was a static IP address, then I could change that in here. Okay? Now, as we go down here, some of the other things that you can set up is the local IP address of the router. Like I just said, 192.168.1.1 is the local IP address of the router. That's the default setting for this particular brand of router. If I wanted to change that, I could do that right here in these boxes. All right. Next thing is you can see that a local DHCP server has been enabled for this router. So like I said, this is going to make the router assign IP addresses to the machines that are plugged into it. And you can see that the start address of the starting IP address of the IP addresses that it assigns is 192.168.1.100. Now, the first part is fixed. 192.168.1 is fixed. I can't change those, but I could change the end. I could start it at 1.50 or 1.150 or whatever I want. And then I can specify the number of addresses that can be assigned by this. Okay, that's just by default set to be 50. I can't plug 50 machines into this 4-port router, but so I could change that to 4 if I wanted, and nothing would ever change. Okay, but this is how you configure my particular router so that it gets an IP address automatically from the ISP, and it also assigns IP addresses automatically to my local network. Now the next thing I want to do is show you how to configure one of the Linux machines in the network, namely my desktop machine, which is Nugget SUSE here, to use the DHCP protocol. Okay, so I'm going to use YAST first, and then I'll show you the different config files that you could edit by hand if you want to do the same kinds of things. Okay, so under Network Devices, I'm going to click on Network Card, and it's got to go through and read some configuration files and so on to open up the YAST screen that's going to allow me to configure this. But basically what we're going to do is configure the Linux machine here to accept IP addresses automatically using the DHCP protocol. Now, the thing is the way that I'm configuring it is, like I said, it's already been configured, so let's just click Change here so that we can see the settings, and I'll click Edit. You can see that it's set up to obtain the address set up via DHCP, automatically obtain the IP address. Now, to the Linux machine, it doesn't matter that it's plugged into the router. It could be plugged in directly to the DSL modem, for instance, which also, will provide an address dynamically from the ISP. Okay, that doesn't make any difference, right? All that we're doing here is we're setting up our Linux machine to accept an address from DHCP. It doesn't matter if it's the DHCP that the ISP is running or if it's the DHCP that the router is running. Okay, it doesn't matter which device it gets the IP address from. We're just setting it up to get the IP address using that particular protocol. Now in here you can also set up some things like the host name and the name servers, the routing information, and some advanced information as well. Things like hardware details or various options that you can set, and you can play around with that stuff. The default settings should work for DHCP for most any Linux system. The other thing about DHCP is that not only do you get an IP address automatically, you also get a name server address automatically. All right, so that's another thing that kind of gets configured. And so the ISP has the sort of the right to give you a different name server each time you started up your computer. All right, what really happens is they basically assign you the same name server each time, and that gets put into a particular configuration file on your system, namely etc/resolve.conf. Okay, so this is the YAST screen that you can use in SUSE Linux to configure your network card so that it obtains IP addresses automatically or statically, whichever you choose. Other versions of Linux have similar sort of configuration tools, like Red Hat Linux has a graphical tool that allows you to set up your network that's very similar in functionality to this. Now, if you want to configure things manually, you can do all of the configuration by editing certain config files. Now, for SUSE Linux, they recommend that you don't do it by manually editing the config files. They want you to go through YAST because it's sort of a more foolproof way to do things. But if you're an experienced user or you're on a distribution of Linux that doesn't have a graphical user interface, then you can go through and edit the various config files by hand. Now that being said, different distributions of Linux will name some of these files slightly differently, so you need to consult the documentation for your particular distribution if something here doesn't quite work for you. But most of these config files are pretty much standard across all the distributions of Linux. Alright, so first, we're in the etc directory, so the first thing we're going to look at here is the resolve.conf file. Now, as we go down here, let's go down to the bottom, you'll see this is where we define the name servers for our system. Now, you can see up here in this whole preface to this, to the actual setting, they talk about a number of different things. One of the things that they mention is that you're allowed to, or that another setting of sort of an environment variable for the network setting can be done in the etc sysconfig network config file or an etc sysconfig network DHCP file, and we'll talk about this directory here in a second. But basically they're saying that you can set an environment variable there so that the DHCP server can modify the name server in etc resolve.conf. I have that set so that it does resolve that, so that it does change the resolve.conf file so that the DHCP server can sort of, you know, tell me what the name server is for this particular session. All right. Now that typically doesn't change very often. My ISP provides the same name server from one time that I turn on my computer to the next, but it did change once a month ago, you know, and they just gave me a different name server for some reason. So that's why I do that, because otherwise then you'd be querying some IP address that maybe they've taken the name server down from there and moved it somewhere else. So that's why I set it to be automatic. Another file is the etc hosts file. This file contains a number of hostname to address mappings. All right, so here it's saying 127.0.0.1 is localhost. You can put other things in here so that you can sort of speed up the translation. Typically, it's only used at boot time before any sort of name servers are up and running. Okay, so but the etc host file is another file that's part of the configuration file. Another file that's an important configuration file is etc host.conf. Now in etc host.conf a few things are set. You can look at the man page for host.conf to get all the different settings, but one of the things that is set is this order here, and this says you know, what order should names be resolved by your system. So the ordering on my system by default was hosts followed by bind. Now hosts mean that it's going to look in the etc hosts file first. If the resolution can't be made from the etc host file, then what it does is it goes and uses the name server. That's what bind means. Okay, so that's another configuration file that's important. Another configuration file, or a whole set of them that are important, is in the sysconfig directory, and then under sysconfig there's a directory called network on SUSE Linux. On some versions of Linux, there's just a file called network in the sysconfig directory, and that file contains things like the host name, IP address, gateway settings, all sorts of stuff is done in the network file. On SUSE Linux, there's a network directory, and then in the network directory are a few different files that contain some information about the network. So network config and network DHCP are both files that we saw referenced in resolve.conf, where we could set environment variables so that in resolve.conf it was talking about whether you wanted the name server to be changed automatically by DHCP, and there were settings in config and DHCP to do that. ifconfig eth with the crazy address here is the settings for my particular Ethernet card. Okay, so this directory has a bunch of config files for you to for you to mess with. Again, things that are in here like host name, IP address, whether you want DHCP to take control of your name server, and so on, that sort of stuff. Once you have your network configured, then of course you're going to want to test it to make sure everything's working the way that you think it should. The easiest way to test the functionality of your network is just, you know, bring up a web browser and start typing in some web addresses. Now, if the web browser doesn't, you know, spit anything out, you know, then you have to determine what's going wrong, and you have to diagnose the error. Now, the problem could be anything from the actual web server is down. It could be that your name server isn't working. It could be that your connection to the internet isn't working, and all sorts of things could happen. So you want to kind of break down that process to distinguish exactly what it is that's going wrong. So one of the things that you can do to make your life easier is try to first start by bringing up a web page that you know is going to be up all the time. Something like Google.com. Google makes their living on the fact that their web servers are accessible 24 hours a day. So if Google.com doesn't come up, then the error is probably on not with Google.com. There is probably some Google servers up. The issue is probably something like your name server's not working, or your gateway isn't, you don't have the correct route configured to get out to the internet and things like that. So let's look at how we can diagnose some of these problems. Well, the first command that we can use is the ping command, and with ping you can determine if a certain computer is reachable from your computer. So can you get to this computer over the network from your computer? Now let's look at resolve.conf for a second. All right. So if, for instance, I tried to bring up google.com or cbtnuggets.com in my web browser, and it said, sorry, I could not resolve the name cbtnuggets.com. All right. Well, one of the things that you can do to test things out is first that you can ping your name server. Okay, so here if I do 205.171.3.65 and I hit enter, you'll see the output of ping here. Now what's happening is the ping command is sending out little packets out to the name server, and then I'm going to hit Control C here to stop it. It's sending little packets out to the name server, and the name server is responding with some packets as well. And you can see down here 10 packets were transmitted, 10 were received, none were lost, and then it gives you some idea of the time that it took, the average time, the minimum time, the maximum time to do that correspondence between you and that address, 205.171.365. Okay, so this tells me right now that my name server is accessible from my computer. If this was the case and it still said I can't resolve, google.com, then the problem is somewhere else. Like if we can access the name server, then that name server should be able to respond with that name. Okay. Now, if I was trying to access like joeschmo.com, and it was this brand new website that just, my friend's managing it or something like that, well, maybe what happens is that that name server, there's a bunch of name servers all over the internet, and if joeschmo.com just started his website up and just got a domain name, that information might not be propagated everywhere on the internet yet. So even though you can reach your name server, you might not be able to get to this brand new website that your friend just started, because the name of his name server and the IP address, that pairing hasn't been propagated to your particular name server yet. That's why I said it's good to start when you're testing out your networking connection. It's good to start with an address like google.com or something that you know is already in all of the name server databases that have been propagated all over the internet. All right, so this lets us know whether we can get to our name server, this ping command. Another thing that you can do is, if you know the actual IP address of a particular website, you could type that IP address into your web browser instead of typing the actual name of the address, right? And so instead of typing google.com, you could type the IP address of google.com, or instead of typing cbtnuggets.com, you can type the IP address of cbtnuggets.com. Remember from the intro series, the way that you can learn what an IP address is for a particular domain name is you can use the dig command, and it will tell you that. So here the dig command is telling us that cbtnuggets.com has this IP address. Now, this is kind of like a which came first, the chicken or the egg question. I mean, to do the dig command, I need to have a name server up and running, and you can see there is my name server that was used to resolve cbtnuggets.com. But if I had this written down like in a logbook or something like that, where I knew the IP address of a particular domain, and cbtnuggets.com didn't work in my browser, then I could just type that in manually and see if that got there to determine if it's my name server that's bad or if cbtnuggets.com is down. If you weren't able to ping the name server, taking a step back, the next thing that you should test is if you can ping sort of your gateway to the internet. Now, the way that my network is configured, like we saw on that first diagram, is that I have that Linksys router between me and my DSL modem. And that Linksys router has a particular IP address, 192.168.1.1. So I can also ping that to see if I can get there. And you can see that this is returning very, very quickly. And so that's telling me that I can reach my Linksys router, and then that Linksys router is hooked up to the modem, which is hooked up to the internet. So this is really like the first step, and this tells you that the very first link of the chain is working, and then if you can get from there out to the name server, then the next link of the chain is working, and so on. Once you can ping the router, then you know that that first link is working. The only reason that it wouldn't work is if you were trying to bring up cbtnuggets.com in a web browser, is maybe your routes are wrong. And the way that you can see what your routes are is by using the route command, and that will tell you what's going on. So here, the default destination, this is for anything outside of the local network, basically. It tells you that the gateway is set up to be 192.168.1.1. So it is configured correctly in this case. If this was not here, though, if this gateway was not here, or if that address was different, then things wouldn't work on my system, because my computer wouldn't know how to get out onto the internet, because either this gateway address is incorrect or it's just missing altogether. All right, so that's an important piece of the puzzle that's telling my computer how to get out to the internet. Another command that's useful for learning about your networking interface and also configuring your network interface is the ifconfig command. This is located in the /sbin directory. And if I don't type any parameters to ifconfig and I just hit enter, it gives me all sorts of information about my network interfaces. Now here the output is two different network interfaces, the eth0 interface and the local interface. Okay, for the eth0 interface, it tells me all sorts of things. It tells me my internet address, my broadcast address, my mask, my net mask. It tells me the MTU for this particular interface. The MTU means that what is the maximum transfer unit that you'll let go across the network. So how big can packets be, basically. It talks about packets transmitted and packets received and all that sort of stuff. So you can learn a lot about your network with the ifconfig command. You can also set various things with the ifconfig command. You can do things like take down your network interface. You can shut it down if you're going to do some maintenance on your system. You could bring it back up with the up command. You can also do things like change the maximum transfer unit size. You could change the net mask and so on, all with the ifconfig command. A command that you have at your disposal for really low-level examination of your network traffic is a command called tcpdump. Okay, so basically what this is going to do is it's going to show you the headers of all the different packets that are traveling by on your network. Now there's lots of different options for TCP dump, and you can sort of limit and filter out the various packets by an expression that you give, and you can look at how to do that in the man page here. Basically what TCP dump does is it monitors all the traffic that's going by, and it gives you some kind of a report. There's certain options in here that will specify where you can say just show me the next 100 packets that pass by. You can also just run TCP dump like this, and then when you hit enter here, what's going to happen is things are going to scroll by at an alarming rate. I'm just going to hit Control-C to stop that, and you can see here it said 556 packets captured, 556 packets received by the filter, and none were dropped by the kernel. If some were dropped by the kernel, it'll give you more information, like were they dropped because there was some buffer problem, maybe a buffer filled up and the kernel wasn't able to write any more packets into the buffer before the buffer got emptied. And information like that is valuable. If your network is behaving sporadically, like sometimes it seems to work, other times it doesn't, or after lots of transfers, then it seems to degrade performance, then a TCP dump might be the way to go for really low-level examination to see what's going wrong. I don't want to go into it too much because, like I said, it's a really low-level tool, but I did want to at least tell you about it because it is a tool that does give you this kind of information, and there aren't a lot of tools that do that for you on Linux. Another command that you have at your disposal to look at the inner workings of your network is the netstat command. With the netstat command, you can do all sorts of things. Everything from printing out the routing table. If you give it the -R option, it's going to print out the routing table just like the route command did. It'll print the exact same thing out to the screen. But netstat does a lot more than just that. One thing that is really useful about netstat is that you can examine the various services that are listening on your system. Remember the zynet-d process from the introductory series. Zynet-d is the Internet Super Service, and basically what it did was it controlled a bunch of other network services on your computer. Things like Telnet or FTP and all sorts of other network services can be controlled through Zynet-d. The problem is if you're trying to look at your network and determine if there's some FTP service running on your network, well, if you did a PS command, you would never see that FTP service sitting there listening because the FTP service isn't really running. It's running through the Zynet-d service. So the PS command to show process status would show information about Zynet-d, but it wouldn't show what services are actually running under Zynet-d or listening under Zynet-d. Whereas with the netstat command, we can obtain that information. If we do a -inet-a with netstat, that will tell us all sorts of things that are out there listening on our system. Okay, it'll tell us for the TCP interface, the UDP interface. It'll tell us when connections are established or when they're just listening. Okay, so you can see up here there's one connection that's been established for a VNC client. Okay, now this command will, like I said, will expose that sort of information to you, and if you see something in there like, oh, okay, there's a Telnet service listening and you don't want Telnet on your system, this is one way to discover that that's running. Then you can go back and reconfigure Zynet-d so that the Telnet service isn't running. So this is a nice way to examine sort of what's open on your system, what ports are open, what ports are listening, and what services are listening on those ports. Okay, well, it's time to wrap up our nugget on networking in Linux. We started by looking at a diagram of a simple home network like what I have set up in my office. And you could see it didn't require much hardware above and beyond the actual machines of the network. I just needed a router to go in between my DSL modem and my computers. Then we started looking at the various configuration tools. First, we looked at a configuration tool that was available through the web browser to configure my router. And then we looked at the SUSE YAST configuration mechanism to configure networking on a SUSE system. Now, lots of distributions of Linux have some sort of graphical tool to configure networking, but if you don't, or if you just want to configure it by hand, I showed you a bunch of files that you could edit to configure networking on your system. Things like etcresolve.conf and etchost.conf. And in SUSE Linux, the etc sysconfig network directory has a bunch of configuration files. And on other versions of Linux, there's a file called network in the etc sysconfig directory that lets you set all sorts of things that are set in the etc sysconfig network directory in SUSE Linux. Then we talked about some diagnostic tools. The ping tool is an invaluable tool to see what you can reach on your network from your particular computer. There was the ifconfig tool, the route tool, and then we looked at some low-level tools like TCP dump and netstat. Well, I hope you found this nugget informative, and thanks for watching.